Hi, everybody. I am so excited that you guys can finally see me when we do these lessons. Um, this is the new format of the live lessons. You can see me. I can see the chat alongside, which means that if you have any questions during the session, then don't forget to put them alongside. I can see those. There's a small delay in the video, which means that it takes roughly about 30 seconds for the chat to update. So if you feel like I've moved on and you've asked a question and I haven't answered it yet, it's because I will see it. It will come up on the side. So don't worry, I will get to you. A couple of things. I am streaming. So if you are a little bit blurry or I look a little bit blurry, it might be just your streaming settings on your side. So if you want to have a clearer picture of me, just make sure that you are watching me in the highest definition possible for your device. And yeah, what I'm going to do is I'm going to do an introduction to the nervous system today. It is just an introduction. We're going to go through the main structures of the nervous system. We're going to go through, if we have enough time, the neurons, and if we have enough time, maybe even a reflex, especially if you haven't learned that just yet in class. I'm going to help you out with that as well. And yeah, if you missed this live lesson, don't worry, there will be more. I know that we are going into exam time now, and we need a lot of revision. And so what I'm going to be doing is popping up polls for you on the members community page. And I would love for you guys to let me know what you want me to cover in those lessons, because every school does the order of topics differently. So some of us maybe aren't doing the nervous system right now. We're doing evolution, we're doing something else. So you let me know. And the last thing I want to say is, remember, if you are a member, you can get access to the cheat sheet for free. You just need to be a Rescue Me member, and you simply put in your request and I approve that, and then you have access to that. Okay, so let us dive into the lesson. I'm going to share my screen now and minimize myself down. And I'm also going to show you a really cool thing that I am working on right now, which is this little board that you can see alongside up here. Now, this is actually an infinity board, which means that I'm going to actually make one giant summary note on the screen for you now. And what's really cool is that I'm going to super zoom in to one particular section over here, and I'm going to talk about the nervous system and give you a bit of an introduction. So let's dive in, and don't forget, you can at any point put a question alongside in the chat box. Okay, so let's dive in. So the nervous system, what's important to remember is that the nervous system is broken down into sections. And so the nervous system, if we break it down into its first component, let me make my screen a bit smaller. There we go. If we break it down, you have the central nervous system. And then on the other side, we have the peripheral nervous system. Oops, the nervous. Okay. Now, remember that the nervous system is responsible for alerting you to sensory experiences. So in other words, seeing and hearing and tasting and touch. So it allows you to sense, but it also is linked to things like movement, balance, equilibrium, and responding to the environment. Because remember, this section technically in your textbook will say something along the lines of like how we respond to the environment. So the nervous system is one way we respond to the environment. The other way is the endocrine system, but that's another topic for another day. And so the nervous system has two ways in which we respond to the environment, depending on what we're using to respond. So the central nervous system is broken up into two components. It's made up of the brain and it's made of the spinal cord. Now, a lot of people don't realize that the spinal cord is an extension of the brain. It's part of the brain. It's not a separate structure. And we're going to go through the structures of the brain shortly. You can kind of see at the bottom of my page here now, I'm going to have a little brain diagram that we're going to label. But then if we go on to the peripheral nervous system, and I move this over to the side here, and actually let me move around. There we go. So the peripheral nervous system is divided into two parts. Now, one of them is called the somatic nervous system, and the somatic nervous system refers to all the other nerves that are responsible for your, let's call them choice responses. So they're not things that you do automatically. For example, something under the somatic system would be like walking, bending your arm, moving. And so the peripheral nervous system is made up of all of the nerves of the body that are not in the spinal cord and that are not in the brain. Okay, so they're all the other nerves of the brain, of the body. And of that, you get the somatic branch of the peripheral nervous system and you get the autonomic. Now, as the name suggests, autonomic means like automatic. These are all the automatic responses of the human body. And the autonomic can actually be divided again into two parts. And when we think about it, there are two divisions of how you can respond, right? And that's going to be the sympathetic and the parasympathetic. Now, what do those two divisions mean? The sympathetic nervous system is what you know as the fight and flight. And so I'm just going to put that in here, the fight and flight. And that's like all of your responses to the world around you that require like quick, immediate reaction and that things that are going to like save your life. Whereas parasympathetic is also known as the rest and digest, which is pretty much probably what you're doing right now. As you watch this video, you're at rest. You are now in your parasympathetic nervous system. So just to recap something, just in case it's not clear when we started this particular section, the nervous system is broken into two main components, right? The central nervous system, which is made up of your brain and your spinal cord. Okay, this is like head office. These are the organs that do the main decision-making jobs, right? But then the decision-making jobs need to be carried out. And that's where the peripheral nervous system comes out. These are all the nerves outside of the brain and the spinal cord, and they're going to carry out the decisions made by the brain and the spinal cord. Now, those decisions that are made can be somatic, which means body. It means things like moving, things that have a choice. Like I want to walk towards a point. That's a somatic choice. That's a somatic nervous system movement. Or it can be autonomic, which means you don't think about it. It just happens. What kinds of things can you think of in your body that just happen? For example, if we have the sympathetic nervous system, the things like blinking when someone throws something at your face, or your mouth drying up when you're nervous. That's all the sympathetic nervous system in your fight and flight. And your parasympathetic nervous system is your rest and digest. So all your automatic functions like breathing and digesting and sleeping and just being at rest, all of those automatic functions are controlled by the parasympathetic nervous system. Now, before I go on to any more, and I do want to dive into the structure of the brain, so I'm going to zoom all the way in over here. We are going to go through the main structures within the brain now, and I'm only going to focus on the ones that you actually need to know, because a lot of people don't know that there are many labels and textbooks and things that you actually don't need to know. And if you use your exam guideline carefully, you will actually realize that there's about I'd say 5 major structures that you actually need to know and their functions. Otherwise, there's no need to go into any more detail. Now, if you do have any questions, don't forget to pop it alongside in the chat, and I can see them, and so I'll be able to answer you. Now, while I wait for you to put in your questions, I'm going to go through the main structures within the brain. This is a cross section through the brain. So if we take a step back, we are going to go through the structures of the central nervous system, starting with the brain, right? And the brain has been cut in half here. There's a cross section here. And what we're looking at are the major structures, right? So we're going to start off with the first main label over here, which is this whole kind of gray structure that you can see on the outside. That is the cerebrum. And I want you to think of the cerebrum as a place in which you think and where you have memory and where you sense. So when you think of cerebrum, think of memories, think of your senses, and also think of your consciousness. That's where you live. You live in that part of the brain, the gray part of this diagram. Now, another important structure that you have in your brain is this lower region over here, which is called the cerebellum. Now, the cerebellum has a really important job. Its job, amongst other things, is it is responsible for actually keeping you alive. So one of its most important functions is that it maintains your heart and your breathing. It does a couple of other things, which are things like, for example, I'm just going to move this up a little bit, which are things like balance and something called muscle tone. And so when I talk about balance, I'm literally talking about the fact that your ears are responsible for keeping you balanced. But how does your brain know that you're balanced? Well, you tell the cerebellum that you are balanced or not. So your ears are constantly communicating with this back region of the brain. And when I say muscle tone, it doesn't mean like you're toned, like your muscles are toned. What it actually means is, are your muscles engaged? And the easiest way to understand what that means is when you go to sleep, you lose all muscle tone. Okay. When you wake up, you regain muscle tone. And the reason for that is you don't want to act out your dreams, right? So you lose muscle tone when you go to sleep. So when you go to sleep, some of your cerebellum switches off so it can rest, okay? But not all of it, because remember, it maintains your heartbeat and your breathing. Right, then let's move on to the next important structure. Now, we can't see the whole thing here, but I want you to know that this pink section coming out the bottom here is the spinal cord. And obviously, it will go down the full length of your vertebra and your vertebral column. And then sitting just above that, do you see this like first little bump, right? There's a bigger bump over here, but I'm not talking about that one. I don't want to talk about that one. We don't need to know that. There's like this first little bump. And that first little bump, everyone, is known as the medulla. Oblongata. You may have heard of that before, yeah? And the medulla oblongata is this very, very important region that is also responsible for your breathing. It's also responsible for things like your reflexes and less important reflexes, like, for example, sneezing and things can also come from this region. It's a really old part of your body in the sense of its like age, right? So it is such a vital section of your whole nervous system. And so I'm also going to put here that it regulates your heart beat and breathing. So it does work with your cerebellum. Okay, they work in like tandem with one another. And then another important structure that we need to know is inside the brain. And there are two important pieces. Now, the first one is this large kind of peachy structure over here. This is called the corpus, which just means body, by the way. It's not like a corpse, like dead. Corpus just means body. And you say callosum. Okay, the corpus callosum. What is its job? Well, it's a dense bundle of connecting tissue, and the dense bundle of connective tissue connects the right and left hemispheres. And what is a hemisphere? Well, the brain is divided into two, a left and a right hemisphere. And so the left and the right control opposites in the body because of the corpus callosum. You see, what I'm trying to tell you is your left side of your brain controls your right hand, and your right side of your brain controls your left hand and your left side of your body. And that is because of the way the corpus callosum crosses over at the back of your brain. You can't see it in this picture, but it crosses over and it goes down your spinal cord and into your spinal cord. And that's why there's like a cross connection. And so that is what the corpus callosum is. And then you'll see sitting just underneath it, let's see if I can squeeze it in over here, this over here, right? This little space here is called a ventricle. Now, you might remember a ventricle from the heart, right? And it's not too different from an actual ventricle in the heart, in the sense that a ventricle just means like a cavity, right? A space. And the ventricles are there for safety. They are there to cushion. They are there to protect the brain. And so a ventricle is filled with cerebrospinal fluid. And that fluid, everybody, is the fluid that creates like a protective cushion on the inside of the brain. So every time you knock your head forward or you knock it sideways, there's like almost like a fluid, like an airbag in the middle of your brain, so that the one side of the brain doesn't knock into the other side of the brain and then it knocks into the skull. Okay, so these are the main components of our brain and their main functions. But now, how do we protect the brain, right? Because this is a really important organ, okay? This is where all decisions are made. This is where I keep my memories. This is where I sense things. How do I protect the brain and also the spinal cord? Well, we're going to have to zoom out here, and we're going to have to make our way over here to this diagram. Now, if you're uncertain as to like what I've zoomed in on here, this, everyone, is a cross section through the top of the brain, and there's a little bit of skull there and some of your skin. Now, when we are protecting the brain, we are going to use membranes to do that. We also protect the spinal cord with these same membranes, so I'd love for you to remember that as well. And in this picture, you can't see the bone around your spinal cord, which would be your vertebra. Oh, I've lost my light. Or you won't be able to see the full skull in this picture, but you can see some of it. So let's just pop a couple labels on here. This is a cross section to the top of your brain and through the top of your head. And so this over here would be skin. And then just below that, you can see the bony layer. There is the skull. So the skull is the first protective layer around the brain, right? But then we've got three protective layers or three protective membranes that sit just underneath that to protect you and to protect your brain. And the first layer is this pale blue layer that we can see sticking out over here. It's the first layer just under the bone. That is called the dura mater. And the dura mater, as the name suggests, is quite durable. It's quite thick. If you ever have brain surgery or you become a neurologist and you actually do surgery on people and you cut through the skull, you will notice it's actually quite difficult to see the brain because there is this thick bag, like this bag-like structure around your brain, and it's the dura mater. Now, the dura mater is followed by another layer, because one layer will not do, and that is going to be the arachnoid. And the arachnoid is this kind of, it looks kind of green, and kind of like long, like tendrils and fibers. And what the arachnoid is are all of the little teeny tiny blood vessels that are providing blood to the surface of the brain. Okay. And excuse me. And finally, this green this green layer, the actual layer touching the brain itself, that is called the pia mater. Excuse me. Now, the pia mater is the final protective layer around the brain. And these three layers together, so let me change my pen color if I can. Let's see, can I? Oh, no, I'm going to stick with the black. I'll stick with black. I'll stick with black. So we've got 1, 2, and 3. Those 3 layers together produce a protective collective structure called the meninges. And may I add, this was a word they asked last year in the final exam. And I felt like when I put this in my prediction video, everyone lost their minds because they're like, I don't know what it is. I don't know what a meninge is. A meninge is a protective membrane around the brain and the spinal cord as well. Okay, so you can get these 3 layers in the same order sitting around the spinal cord. Okay, so once again, I'm going to take a little quick break as we move around on our picture. And I want to remind you, if you have any questions for me, or if you want any clarifications as I move along, please let me know and I will do that for you. And obviously it comes up on the chat that I can see that. But if you have anything, let me know. What I want to do next is I want to introduce you to some smaller components. And I want to be able to maybe touch on the spinal cord as well today, because we've done the brain, right? And we've done the meninges, but I think if we get that far, which we might not be able to do a reflex today, but maybe I can introduce you to the spinal cord just before we go. I think let's do the nerves first. I think that's a better one. Okay, before I do, Kishni has a question. Please explain what is a pia mater. So the pia mater, I'll just quickly go back here. That one there. Okay, this is this one over here that we're referring to. The pia mater is the innermost meninge, so it's the innermost membrane, and like the other meninges around the brain, its function is to protect our brain, and it is the soft inner layer. So if you were to classify the 3 layers, the pia mater is the soft inner protective layer. Then you have the arachnoid, which provides blood vessels and blood to the area. And then you have the dura mater, and the dura is the outermost layer. It is the most dense and fibrous layer, and it provides the first line of protection before the skull. Grace wants to know how in depth about the meninges do we need to know. You just need to know their names and the fact that they provide protection. That's all you need to know. Brooke wants to know any textbook recommendations alongside my study guide. I personally at school use, for the life of me, I cannot remember who makes the book, but it's that purple book. It's a purple textbook. I think it's the Mind Action series, and that's what I personally use. And there is some flaws in it. Like there's some things I don't love about it, but out of all textbooks, that is the one that I like most. And if you watch some of my oldest videos on YouTube, it's actually the book I used to teach some of my very, very early on lessons when I was doing it back during lockdown. Okay, so I hope I've answered some of those questions for you. I think to make it make sense, because I want to marry all this knowledge together, I think I'm going to just quickly run over the spinal cord before I get to neurons, because I think maybe I'm going a little bit too fast here. So if we go back to our little diagram over here, we have done the central nervous system first. And so we've covered the brain structure, right? Now we need to cover the spinal cord structure. And so we're going to do the basics for now. We're not going to get too crazy. You do need to know quite a bit of detail about your spinal cord. And so please don't ignore it when you study and you prepare for your exams. A lot of students do, and then they realize, oh shoot, I need to know a lot more than I thought. Now, for now, what I just want to focus in on is what is inside the spinal cord. So what you're looking at here is a cross section through the spinal cord, and you are looking at two different colored matters. And so the brain is exactly the same. It's also made out of what we call white and gray, but they are inverse, or they're swapped. But I'm getting ahead of myself. Let me label it and I'll show you what I mean. So first of all, if we look at this is the cross section of our spinal cord. And one of the most common questions I also get is, ma'am, how do I know the top of the spinal cord? Like, how do I know that's the top and that's the bottom? What happens if it's like upside down in an exam? Okay. So when you are looking at a spinal cord diagram, do you see this like little cleavage space that it's being created here? That is always on the inside of the spinal cord. In other words, the inside of you. So this would be the top or the back of you, like your back, your actual back behind you. That will be behind you. So that's the top. And this is technically the bottom or the inside of you, like on the inside of your spinal cord, closest to like all your internal organs. Okay. Now we've cut the spinal cord in half in this picture. And there's a couple of things that I want to label for you. The first is this like brownie colored matter on the outside is actually called white matter. And white matter is white because it contains something called myelin. And I'm going to get back to what myelin is now soon. And this is also why it's difficult for me to make up, do I want to teach you neurons first or do I want to teach you the spinal cord first? But we'll do the spinal cord first. So it contains a lot of myelin, and myelin is fat, basically. And that's why it has like a white color to it, because it's mostly fatty. And the white matter also contains a large amount of sensory and motor neurons. And I'm going to tell you what a sensory and a motor neuron is before the end of this lesson today. So that's what the white matter is. That's what's inside the white matter. It's fatty, so it has this white appearance, and it's got a lot of sensory and motor neurons, so sensing and moving nerves and neurons. Then you will notice we have this darker gray matter on the inside. Now, the gray matter is really important because this is the part of your spinal cord that's going to do a lot of decision making. Okay. And who's making the decision? Well, it's mostly made out of what we call interneurons. Again, I'm going to introduce you to who they are today, and then I'll come back to this picture and link them together. And the reason why it's gray is because it lacks the myelin. So it lacks myelin. There's none there. And it all has to do with the purpose of interneurons and the fact that they don't need the fat. Now, there are many other reasons why gray matter is the way it is. For example, it is there for primitive reflexes and integrative reflexes. But I'm going to get back to that at a much later lesson, not today, because there's a lot more that we could cover there. Now, the one thing that I do want to cover, which I didn't explain at the beginning, is if I just quickly go back to our meninges picture. Where are you, meninges? There you are. You will actually notice, if I go nice and close, that the gray and white matter have actually swapped locations. You will notice that the white matter is on the inside and the gray is on the outside. And so that's an important difference between the spinal cord and the brain that maybe you should note that you didn't know. Again, why is that the case, ma'am? That is the case because of what the brain does versus what the spinal cord does. And the matters, the colors, indicate the function because you want a lot of gray matter versus white for different functions. And then you want more white than gray so that you can do a different function as well. It's all about their functions. And I think maybe it'll be a bit easier once I've now covered neurons. And once you understand what a neuron is and where that myelin, that fat is, it'll make more sense why the brain has it the other way around to the spinal cord and why there is more gray matter than white matter in the brain. And in the opposite, in the spinal cord, there's more white than there is gray. So if we kind of zoom out for now, and I just want to give you a little overview of our spinal cord, because remember, we're not done yet. You will also notice that there's this little central canal down the center here, central canal. It's also filled with spinal fluid. If you want to use the full name, you can, which is cerebrospinal fluid. Again, what is the purpose of cerebrospinal fluid? It is for a cushion. It's the same fluid inside your brain as a little airbag, right? And then what you have coming out of it, you can see this like little extension on the side here, this little extension here, and you've got one here as well. These, I'm going to join them together. For now, we are just going to call these spinal nerves. They actually have more specific names, but I will only do their specific names when we start to do reflexes, which is not in today's lesson. We'll need more time for that. So if we kind of zoom out here now, we've got a rough idea of what our spinal cord looks like. And if I try and get everybody in focus at the same time, for now you can see we've done an introduction to the nervous system, the brain, the meninges, you can see the spinal cord. And the final component, which we haven't tackled yet, which will be the last thing that we're going to cover today, are the neurons. And so the neurons are the smallest functional component of your nervous system. And so once again, if we now refer back to our original diagram of how the nervous system is broken up, we've done the brain and we have done the spinal cord structures, right? But now how do we get the information from the brain and the spinal cord? How do we get it from there and send it to the peripheral? And also the other way, how does the peripheral tell the nervous system what's happening with the body? Well, that is where neurons come into play. Neurons are cells, right? They are nervous system cells. And there are three main kinds we need to know. I would also like you to know the following things. Number one, you will have to be able to identify these neurons just by looking at them in an exam. Without labels, without any guides, you're going to have to know what these three are. And I'm going to show you the easiest, simplest way to tell the difference. And then we'll go into a lot more detail of the actual structure. So let's begin with the three kinds of neurons that you get. The first kind you might be more familiar with because it looks familiar is a motor neuron, right? So this is a motor neuron, and its main function, as the name suggests, is movement. Now, you find these a lot in your muscles and the glands of the body. And that's because motor neurons are found in effectors of the body. So like places where you need to carry out functions. And so the motor neurons do that. Now, how do I know a motor neuron is a motor neuron? Well, you are going to look for this big green swollen section called the cell body. When the cell body is surrounded by these little branches here called dendrites, you know you are looking at a motor neuron because the cell body is surrounded by the dendrites. And now if you look at the other two, you can see that there's a clear difference. Motor is the easiest one to identify. It's the next two that a lot of people have trouble with, okay? The next one, our middle one, is a interneuron. Now, the interneuron is a neuron that is going to be found mostly, if not exclusively, in the spinal cord and in the brain. So first of all, if I write what its function is, the interneuron is for integrative function. You see how their names are kind of linked to what they do? Integrative means thinking and choices. That's what it means. And so an interneuron is there to integrate information. It's to take the information in and make a decision. And where do we find it? Well, we mostly find it in the brain and the spinal cord. That's its main location. Okay. Now, how do we identify it? Once again, we look for the cell body. And do you see that the cell body is off to the side here? It's got this little extension here. That is how we know we are looking at an interneuron. Now, last but not least, and these two are the ones that get confused. So interneurons get confused with sensory neurons. Once again, as the name suggests, which I think we're all going to guess what this one does, this one is where all of your senses are interpreted or brought in. And so your sensory neurons are the neurons that are connected to the senses or the sensory organs, like the eyes, the skin, the tongue and the mouth for taste, your ears for hearing. And so sensory neurons collect the sensory information and they send it through to your brain. And so we find those in the sense organs. We also call the sense organs the receptor organs. That's the more formal name for it. Now, there's actually an order of operation here. This is the last thing I want to do before we do a lot of detail on the neuron structure. And what I mean by that is these three neurons work together with one another, and they send information from one to the next in order to communicate. So let me take a step back and say this. Let's say I want to feel this pen in my hand and I want to feel it. Now, the feeling of it, my fingers touching it, that is generating a sensory impulse through a sensory neuron in the skin of my fingers. So I can feel this pencil or pen that I'm holding. Now that has to travel all the way to my spinal cord and to my brain. So information often flows from a sensory neuron to an interneuron. And an interneuron, either in my spinal cord, but in this case in my brain, is going to receive that information and it's going to integrate it, meaning, oh, wow, that pen feels smooth. It feels cold to the touch. And it has all this information that it is working with to determine what I'm touching, right? But now let's say I want to move the pen around while I hold it. Now I can hold it and I can feel it, but now I want to move it. Now the interneuron will make a decision. It will say, well, we're touching this smooth pen, but we want to move it. It then sends a piece of information, an impulse from the interneuron to the motor neuron. And the motor neurons and the muscles in my finger allow me, and my wrist, allow me to move the pencil around, and it's communicated with one another. Now, you will notice it is a one-way direction. It doesn't have to be in my picture from right to left, but what it is important is that information is always going from the senses to the interneuron, which is in the brain or the spinal cord, and then over to the motor neuron. Now, it doesn't always have to get to the motor neuron. In other words, there could be a break here where it just gets to the interneuron, because do you agree that you don't always have to move? You don't always have to react. Some things you're experiencing, like senses, you don't have to do anything. Like listening to me right now. Your sensory neurons in your ears are hearing what I'm saying. They're transmitting that impulse to your interneurons in your brain. Your interneurons in your brain are interpreting that information and hearing me right now and understanding the words that I'm saying. Do you have to move? No. So you don't always have to go from sensory to interneuron to motor. You'll only go to motor if you need to move. Now I'm going to take a quick breath there. And I'm going to ask if there are any questions on these three main kinds of neurons. If there isn't, I'm going to go into the structure or the basic structure of a neuron, because for now, all I've done is just identify them and show you how to identify them, which, oh, by the way, I haven't told you about sensory neurons. Let's do that one quickly. Sensory neurons have their cell body, as you can see, right in the middle of themselves, like right in the middle there. And this is a tricky one because I haven't taught you yet the structures yet. But what you find is that the cell body is inside of something called the axon. Whereas on our interneuron over here, it's sitting off from the axon, like to the side there. But once again, don't worry, I am going to go over the cell bodies and the axons and like what are all these things, because that's going to be our last little bit for this lesson today. But if you don't have any questions on the neurons, don't worry about it. You can also leave comments on this video, because once we finish the live, it gets uploaded immediately and you can leave me questions and I can reply to you. Okay. It's another benefit of being a member, because when you comment, I do get a notification. Okay, Brooke has a question. Will the interneuron and sensory neuron also have dendrites? Yes, yes, they do. Okay, and so I haven't drawn them in here or labeled them, but these over here are the dendrites. So those are dendrites, and these are also dendrites on the other side. So they do also have dendrites, yes. And the motor neuron also has axons in the same places. So axon is here and here and there. So they also have axons as well. It's actually all about where the cell body is that tells you where the dendrite and the axon is. But I'm going to do that now for you. I'm going to label that for you. Okay. So maybe this will also help Brooke. Let's go over to this lovely picture here. Now, this, everyone, is a motor neuron. I chose it because it has everything in it, and it's the most common picture that we see in exams and tests and textbooks. It's also the easiest neuron to identify, and it's just lying down on its side. Okay, don't be worried that it's not the other way around. Okay, so let's run through the major structures in our neurons. And these are all the structures that you need to know. There's about 6 of them, and I'm going to start from the top. Now, over here, these branchy structures are the dendrites. I've already introduced them to you. And yes, all neurons have dendrites. I just want to have a quick read. There's a question from Keshni. How will they ask the questions of neurons in the exam, and will we have to draw them? Okay, so yes, you will have to draw them, you will have to label them, and you will have to identify them with reasons. So how do you know this is a motor neuron? How do you know this is a sensory neuron? How do you know this is an interneuron? Then they could ask you, what is the function of a dendrite? What is the function of myelin? What is the function of a axon? Okay, so to summarize, how will they ask the questions on neurons? 1, they will ask you to draw them or label them. So that's 2. They will ask you to give the functions of all the structures. They will ask you to identify them, like which one is which. And when you identify them, how did you know it was that one? Okay, lovely. All right, so the dendrites, they're at the end there. They're multiple branches. Now, sitting just below that, this whole swollen region, and I'm going to make this a long label here, is the cell body. And the cell body, if you look at my diagram carefully, has some familiar structures in it. You see this round purple structure? That's the nucleus. And if you look very carefully, you can see some mitochondria, you can see some ER, you can see some Golgi body. So the cell body is essentially like the main part of the neuron of that cell. Now let's move down. This whole section, this whole thing, and this is really important, everyone. This is an axon. Both the straight part and the branchy bit at the bottom, that's all an axon, that whole thing. And a lot of people get a little bit like flustered because they're like, but dendrites are just the branchy bits on the one side. Aren't those also dendrites at the bottom here with the little knobs? No, 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 no. Everything from the cell body down is an axon. Okay, so that's all an axon. And the purpose of the axon is to conduct an impulse and to conduct it to the next dendrite of the next neuron. Okay, but I'll get to that. Okay, let's finish labeling it and I'll put all the pieces together. The next thing I want to label for you is this outer layer, and that is the myelin. So if you were wondering where it is, this is the myelin sheath. It is a fatty layer, and its purpose, everyone, is to speed up impulses and to contain impulses. So I want you to think of it as an insulator. You know, like with electrical cables, you always have like plastic or rubber around them to prevent you from shocking yourself. Myelin does exactly the same thing. It just makes sure that the electrical charge is inside the neuron at all times. Okay, so it's not going in places it doesn't belong. So that's where the myelin is. And so if you don't have myelin, like we mentioned earlier with the white and gray matter, you will be gray. If you have myelin, you'll be white. Okay. Hamida asks, does the interneuron have a body cell? Yes, it does. I will go back again and kind of put all of this together for you so you can see how it all links, but it does. Okay. So the myelin sheath is on the outside. Then what else have I not gotten to? Oh, yes, these. So what are these knob things on the end here? And like, what is their purpose? So they are called a synaptic knob. Okay, synaptic knob. And essentially the synaptic knob is where one neuron is going to transfer an impulse to another neuron. So let me draw it so you know what I'm talking about. Let's move this picture over slightly. I want you to imagine, okay, that there is another dendrite, another neuron sitting here. So there's a dendrite, here's another dendrite, and they're all coming together into a cell body. And so there is, I'm just going to go around that. There is the nucleus of the cell body. I wonder if I can get rid of that. No, my eraser is not erasing. And then it goes down. And then there's your myelin sitting on the outside. Again, just like my other one. Okay, and if I move it over slightly, it'll go down, 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 more myelin. And then it will branch out again with more synaptic knobs on the end, all right? So it's like one neuron hovering really close to the other. So the dendrites and the synaptic knobs, or the synaptic terminals, that's another word for it, they never touch. They're like really, really close. And you can see I didn't make them touch. If we zoom in, I didn't make them touch. There's a space there, and let's actually close them off like that. They don't actually touch, okay? And so what happens is, if I zoom out a little bit so we can see the one neuron going into the next, what happens is an electrical impulse is going to travel down the dendrites, down the axon, down the synaptic knobs, right? It's going to jump to the next neuron, and it's going to travel down that neuron's dendrites, down its axon to the synaptic knobs, and then it's going to get to its final destination. And that destination being potentially your muscles, moving. You're going to contract the muscles, you're going to move them, right? Now, how do we put this all together? And we're going to answer Hamida's question about the cell bodies and neurons and putting all these pictures together. So if we have a better understanding of like the neurons themselves, if we go back to this drawing over here, once again, we can look at the cell bodies. So they all have cell bodies. They are these green regions here. And I have labeled all three of the cell bodies. You will see they all have cell bodies, right? All of them. They're just in different locations. Now, the final thing that I want to point out to you is, as I mentioned, they all have cell bodies. They all have dendrites. They all have axons. The key, which a lot of teachers don't know, and I would love for you to all remember this because I think your teacher would also be impressed if you knew this before she or he taught it, was where do the dendrites and axons actually begin and end? Okay. So let me show you something. If we look at the motor neuron, everyone, the dendrites are all around the cell body. Those are the dendrites. But everything from the cell body down is the axon. Okay? Pay attention to this part, please. This is important. If we go to the interneuron, however, everything before the cell body, everything I'm circling here now, everything there is a dendrite. Everything after the cell body is an axon. So the cell body indicates what is a dendrite and what is an axon. Let's do it to the last one on our sensory neuron. Everything before the cell body, dendrite. Everything after, axon. And if you know that, I'm pretty sure your teacher will be really impressed because a lot of students don't know that fine detail, and it is really important. Why is it important? Well, we're going to have to leave that for another lesson because that is going to go into reflexes and how electrical impulses move through your body, through your neurons, and how your neurons actually do their job. Now, once again, we're going to wrap this lesson up and I'm going to say goodbye. If there are any questions for me, please don't forget that you can, of course, leave a comment for me down below in this video. And I will be having more of these lives as we get closer to exams. And also just a little punt for those of you who are still here watching this video, I have made a whole university application series that I also think you guys should go and check out. It's about how do you apply for university, how to prepare for NBTs, how do you fund your university experience, and also if you chose Maths Lit, what can you study with Maths Lit? And there are some other videos that are going to be coming out that a lot of you are going to be interested in, especially if you've taken life sciences, as you probably have, and what can you study with that. Before I go, I'm going to do one last question from Shaylin, which says, when studying for this section for finals, do we only need to study what's in the exam guidelines? Yes, yes, yes. Yes, yes, yes. A lot of teachers expect you in your prelims or your mock exams to know a lot more than you actually need to know. It's important that the guideline tells you what you need to learn. That's exactly what you need to know. And the final will only test you on that information. And so you don't need to study all that other stuff. And when I say that other stuff, it basically means sometimes some teachers want you to know a lot more detail than you actually need to know. And lastly, I also want to point out, if you are a Rescue Me member and you have access to the study guide, the cheat sheet, I also have used the exam guideline to write that. And so everything that's inside of that study guide is exactly what you need to know. No more, no less. That's why it's only about 130 pages. And that's so it can be simplified for everybody so that you don't have to unnecessarily study stuff. Okay. I'm so glad that you enjoyed this lesson today. If you've missed anything and you want to watch it again, obviously this will be uploaded. And of course, don't forget to make sure your notifications are turned on so that you get notified when I go live next and when I post for it. And I will see you all again soon. Bye.